Good day, everyone. Uh, Today we'll be looking at this question on that frictional force. Remember the last class we did under this topic, and I hope you have attended that class. If you have not done it, you can go back and watch it. Frictional force by the Best Academy, because that is the basis of this particular question we're about to solve now. The first one we did was on the plane, just horizontal plane, not inclined. But this particular question now is inclined to the horizontal by 60 degrees. So the question is, a mass of 60 grams rests in limited equilibrium on a rough plane inclined at 60 degrees to the horizontal. Find the coefficient of friction between the mass and the plane. I repeat, a mass of 60 grams rests in limited equilibrium on the rough plane inclined at 60 degrees to the horizontal. Find the coefficient of friction between the mass and the what and the plane. You can see this the options we have: A root 2, B root 3, C root 5, D 2 root 3. So which of the options is the actual correct answer here? So if you know you have not subscribed to the channel, please try and do so, and also try and like this video and share to others. So let's look at the solution now. All right, remember the first one we looked at was just a plane, horizontal plane of a plane of this nature, and a mass was on top. I told you, if the weight is going down, the normal reaction will be going up. Then the frictional force will either be going this direction or to the other direction, in the horizontal direction, while the normal reaction will be the vertical direction. So what we're trying to say now, what about if this plane is now inclined at a particular angle to the horizontal? For example, if I move this particular plane now to somewhere here, I will raise this one up to this place. So that's what I'm trying to say. I'll just raise it. I'll raise this part up like this plane now, and now raise it up. Look at what I'm trying to say. I will now raise the plane up. The stuff will now be like this, something like this. It will not be horizontal again. It will now be making an angle of 60 degrees to the horizontal. Go 60 degrees to the horizontal. That's what they are trying to say. So the mass will still be on top, and this mass is not slippery. That's what you know. It's not going. It's just still there. So what will be the coefficient of friction to keep this mass here, so that it will not slip through the ground? That's what we are trying to look at now. So what is the coefficient of friction between this mass and the plane? So the mass is 6 grams and 6 kilogram, and the angle is of inclination is 60 degrees. So let me quickly explain this concept so that you'll be able to, because we are looking for coefficient of friction. I told you in the last class, coefficient of friction is what? Frictional force divided by what? Normal reaction. I've already explained that. So this is the same formula we're still going to use. I'm going to come from somewhere now. Let me explain this particular concept very well so that you understand it better. So I'm now looking at an inclined plane now, something like this. The mass is still like this. The mass is still here, but the plane is not inclined. The normal reaction will be going up. The normal reaction, but the weight will be going vertically downward, because this one is the weight. So that is W. I already explained the W to you. And this theta, the angle between this stuff and then the frictional force will be going either this side or this side, parallel to this plane. So let me say the frictional force will be going, since this thing will try to slip downward, frictional force will be going to this side. Let's say frictional force. So take note of this. If you have something like this weight here, this reaction here is also vertically opposite to this plane, something like this. It's coming this way. So it's coming this way. This is the line of action of the normal reaction. So the angle between this weight and this line is still the same thing as this theta. Both of them are the same. The angle between this and this is the same thing as this angle between this theta and this. What I'm trying to tell you is that if you have something like this, let's say you have something like this, just like this in geometry, if you have something like this, then let's say it's not like this. And sure, this is a straight. This must be a straight line. No, this one must be a straight line. This one must be 90. This must be 90. This one is 90 degree. This theta here will be equal to, if you have something like this, will be equal to this theta here from geometry. Because look at how to do it. This other one will be 180 minus theta minus 90. This one will be, let me call it alpha. That alpha there will be equal to 180 minus 90, which is this particular one, then minus this theta. So that will be equal to 90 minus theta. That's what you're having there. Then if you want to look for this other one now, it will still give you theta. Let me first call this one beta. It will be equal to theta later. So this other one will be this other line now should be perpendicular to the plane. And this line should be perpendicular to this plane because this normal reaction is perpendicular to the plane. While this frictional force is parallel to the plane. That's the only thing you should just take note of. Perpendicular means you make an angle of 90 to the plane. And that's what I'm trying to say. So if this one is perpendicular to this plane now, it's also perpendicular to this other side. So to look for this beta now, beta will be equal to theta. That's what I just want to show you now. To look for that beta, look how to get it. Look how to get it. Already gotten that this one is 90. This particular alpha is 90 minus theta. If this one is perpendicular to the plane, that's one to be perpendicular. We are going to have something like this. Okay, let's call this one beta first. I already said that. So that beta now will be equal to, look at it too, be equal to 90 minus this particular one here, because this one angle here will be 90. The full angle is 90, and that particular one is 90 minus theta. So that will be equal to 90 minus 90 minus theta. So that will be equal to theta. Okay, minus times minus will give us plus. Minus times minus will be equal to plus theta. So that everything there will be equal to 90 minus 90, that is gone. So everything will be equal to theta at the end of the day. So I already told you this one is equal to theta. So take note of that. It's also very, very important. So I just showed you. That's from geometry. That's why I have to know geometry very well. It's very good if you know geometry. So let's look at this particular diagram now. So what we are going to do, we are going to resolve this stuff to the vertical component and horizontal component. So look at what I'm going to do now. I'm going to bring this thing down again. I'm going to bring I'll bring this plane down to this place so that you understand it better. If I bring this plane down to this place, for example, now we just make it horizontal. I'm going to have something like this. Let's say the line is now horizontal. The weight will come to this side. This weight will also shift to this side. Then this one will now be vertical like this. This will be the normal reaction. Then this will be the angle between the weight and the normal reaction. And the stuff which is the frictional force, we'll be going to this direction, which is R. So if you know how to do this thing very well, relation of forces, I also should teach you how to do relation of forces here so that you just get it better. Now this angle is between this what's it called, weight and the vertical line. This vertical line. So I'm going to also teach you guys how to resolve forces in a very short way. So although this question can be solved in a very short way, I just want to explain something. I also just want to explain relation of forces. Let me quickly show you guys how to resolve forces here. So let's resolve this W now. Remember, upward force will be equal to downward forces. So arrow will be equal to downward force. Now resolving this one to this place. So that will be something like RT along the y-axis. If you want to resolve this W to the y side, what you do, you use this W to multiply cos of this theta, because the theta is with the vertical, not with the horizontal. So I'm going to have W cos theta. Or you can also say, since W is equal to M times G, you can say mg cos theta. That's what I'm going to do. Then our R, which is normal reaction, which is the frictional force. This particular one, which is the frictional force. So it's frictional force. So it's frictional force. Frictional force. This frictional force. So that frictional force will be equal to the same thing. The component of this one going to this horizontal side. Going to this horizontal side. The one going to the vertical side is W cos this theta. The component of this particular W now go to the horizontal side now, or the amount of W go to the horizontal side will be W sine theta. That will be equal to mg sine theta. Sine theta. So the stuff now, remember this for arrow, and remember this for W and for V, F. Take note of those two things. Now the question of friction now which we are looking for will be equal to F frictional force over R, which is mg sine theta divided by mg cos theta. So if mg cancels mg, sine over cos will be equal to tan theta. I don't know if you understand what you are doing here. That means actually the equation of friction for an inclined plane will be equal to tan theta. Equal to tan theta. That means we don't actually need the mass. So the equation of friction here now will be equal to tan theta. Will be equal to tan theta. For any inclined plane, equation of friction is equal to tan theta. Let's say what is the equation of friction? As well as the only thing acting there is frictional force and normal reaction. If there's no other force there, the frictional force will be equal to tan theta. And the answer to that question will just be tan, what is theta? 60. And what is tan 60? Tan 60 is equals to 3. That is all. So if you know this concept that for an inclined plane of that nature, the coefficient of friction is equals to tan what's it called? Tan theta. You just say the answer is equal to, you don't even need to solve. From the question, you just click on tan of the angle there, then you get the answer and leave there. That is all. Okay, let me show you another question. Let me just teach you guys another question from here so that you understand what I'm trying to say. You understand what I'm trying to say? I'll just teach you guys another question now so you understand what I'm trying to say. For example, now let's say we have something like this. Another question. Let's say the same question though. A mass of so and so. Let's say 3 kilogram. Rest on limited equilibrium at an inclined plane of, let's say the inclined plane is now theta equal to 30 degree. 30 degree to the horizontal. Or 30 degree to the horizontal. What is the equation of friction? Mu. The equation of friction will be, you don't need to be doing all those derivation. That one is just to explain something. It will be tan theta, which is tan 30. And if you press tan 30, it will be 1 over root 3. That is the answer. 1 over root 3. You are through with the question. You are true. That's what I'm trying to say. So please ensure you understand this. So the answer to that question is tan. The question is that mu is equals to what? The question we just finished. That question we are looking at, which is tan 60. That is equal to root 3. That is the answer to the question, root 3. So please take note of that. As simple as that. Thank you.